Welcome, fifth graders, to the Dallas Independent School District STEM Environmental Education Center. I'd like to give a special welcome to a number of schools who are with us this morning. First, we have students from Charles A. Gill Elementary. Next, we have students from Clinton P. Russell Elementary. Third, we have students from Nathaniel Hawthorne Elementary, and those are all from the Dallas Independent School District. And then last but not least, we have fifth graders from Johnston McQueen Elementary out of Longview ISD. Thank you so much for joining us this morning. We wish you all could be here in person, but since you can't be here in person, we're going to do our best to make you feel like you're here during a virtual field trip today. If you are watching this and have not registered for this field trip yet, you can still do that by going to www.tiny.cc/EEC register. And once you get there, you can get yourself or your class registered for this field trip. We just use that information for our attendance purposes. And today's field trip is going to be all about Earth's changes. During this field trip, students will discover that Earth's surface is constantly changing and consists of useful resources. Students will explore the processes that led to the formation of sedimentary rocks and fossil fuels. Students will also recognize how landforms are the result of changes to Earth's surface by wind, water, and ice. So we're going to start things off this morning by discussing how sedimentary rocks and fossil fuels were formed by Mrs. Fuller. Next, we're going to explore some deltas and canyons with Ms. Nash. Third, we're going to explore sand dunes with Mr. Ramirez. And last, we're going to see stream tables with Mr. Monroe. While we're doing all of that, you can ask us questions, and we encourage you to ask questions. Since this is a virtual field trip, the way you ask us a question is you go to www.tiny.cc/EEC-question-answer. And once you get there, you'll fill out a super short form to ask us any questions you have related to Earth's changes. You can ask as many questions as you like, and we will do our best to answer all of them in the time that we have with you this morning. So let me stop sharing my screen here and turn things over to Mrs. Fuller, who's going to get us started with sedimentary rocks and fossil fuels.
Good morning, boys and girls. We're going to be talking today about the forces that form sedimentary rocks and fossil fuels. Let's start off by talking about energy, which is the ability to do work, and forces, which are a push and pull. The forces act on the sediment, that forces act on the fossil fuels. They're not part of it, but they act on it. Let me share my screen with you, and we're going to look at a little slide presentation that is going to help inform us of those processes, of those forces. So processes that form sedimentary rock and fossil fuels are erosion, deposition, compaction, and cementation. If you'll look at the picture at the bottom, those are sedimentary rocks. They illustrate the property of horizontality. That is, in general, sedimentary rocks are formed in a horizontal fashion, and they also exhibit the law of superposition, which means that younger rocks are at the top and older rocks are at the bottom. Now we start with weathering. This is the breaking down of rock by chemical or physical or even biological means. Now let's start on the left. That's Half Dome, one of the most important and famous rock formations in the United States. It's in Yosemite National Park, and Half Dome is exfoliating. That's a physical type of weathering where a top layer pops up and cracks into pieces and then falls off. We've got all different kinds of physical weathering, such as iced wedging or frost action, different things like that. Now, the picture in the middle shows chemical weathering. This rock had acid rain fall on it, and the acid in the acid rain destroyed some parts of this rock, changing it into something different. In chemical weathering, the rock is changed chemically into a different substance and then becomes sediment. Now, before I go to our darling little prairie dog there on the right, I do need to remind you, last year in fourth grade, you learned about sediment. Sediment is little broken pieces of rock. So the prairie dog and plants actually, they can all break rock. They can weather rock. The little prairie dog does it by scraping away. Look at his sharp toenails. He can scrape away the rock with his sharp toenails. Plants can put their roots into rocks and crack them apart. Now, after we have weathering, after the sediment has formed, then we have erosion. Erosion is the movement of sediment. So in the picture on the left, the sediment was moved, it was eroded by wind, which blew it away. In the middle, there's the Grand Canyon, and in the middle of that is the Colorado River, and the Colorado River is moving the sediment down the riverbed. It's eroding it. On the right-hand side, we see a landslide. It's probably a small one, like maybe slump or something like that, a small bit of mass wasting. This is caused by the action of supersaturation by rainfall and then gravity. Gravity pulls it down. So that's erosion, the movement of sediment. The next one is deposition. Once it's been eroded, the sediment does not stay in the erosional force forever. If it's being blown by wind, eventually gravity will pull it to the ground. If it's being eroded by water, eventually gravity will pull it down as the water loses energy. On the left, we see Great Sand Dunes National Monument. I've been there several times. It's quite impressive. It is an enormous amount of sand that was weathered in Colorado, and the wind blew it up to the base of the San Juan Mountains, but it can't escape. So it's stuck there. So it's forming these sand dunes. And Miss Ramirez is going to talk to you about the formation of sand dunes in just a minute. On the right-hand side of the paper of the slide, we see sediment that was eroded by a flash flood in Arizona. You can see the saguaro cacti in the background, and as the waters of the flash flood lost energy, it deposited, it dropped the sediment by the force of gravity on the roadbed. The next one is compaction. Compaction is very important when we talk about the formation of sedimentary rock. Very often, if you'll look on the left, the sediment is all piled up and there's lots of spaces for air and water to fill in. When it gets compacted, when something pushes on it, we generally call the sediment that gets put on top overburden, and that will mash it together so that the little spaces are tiny instead of small. Look at those little tiny spaces. What can get in there? Air can get in there, but water can get in there also. So after compaction, we have cementation. Water, which is the universal solvent. You learned that also in fourth grade when you learned the properties of water. Water can dissolve more things than anything else. A lot of minerals will dissolve in water, and the water solution with the minerals can go in all those little tiny cracks. When the water evaporates, it leaves the minerals behind. So I've got several kinds of sedimentary rock for you to look at. Look at the one on the left. This is conglomerate. The sediment size is pebble size, and it's cemented. That means glued together. It's cemented by some sort of mineral, perhaps gypsum, perhaps calcite, calcium carbonate, maybe silica. Look at the one in the middle at the top. This is sandstone. The sediment grains are the size of a grain of sand. That's why it's called sandstone. And it also got compacted and cemented to form sandstone. Below that, you see a type of sedimentary rock that has fossil shells embedded in it. This is called coquina. And then over on the right-hand side, you see a very crumbly kind of sedimentary rock called shale. The sediment size in shale is the size of mud particles, very small. This falls apart very easily. Then finally, we're going to look at some fossil fuels. On the left, we can see the little tiny planktonic organisms that form petroleum and natural gas. Petroleum, petro means rock, oleum means oil. So petroleum forms from plankton, zooplankton and phytoplankton, but it's very old, 400 million years old, 500 million years old. The little organisms died, fell to the bottom of the ocean, were covered with sediment, were covered with lots of overburden, were compressed, and over the millions and millions of years formed fossil fuels. If you look at the picture on the right, those are swamp plants. Coal formed from swamp plants. So I'm going to, and the swamp plants died, fell over, were compressed, and if they had a little bit of an overburden, they formed lignite. A lot of overburden, they formed bituminous because all the air and water got squeezed out. And then finally, anthracite. So I'm going to, escape this, and I'm going to stop sharing. And I'm going to show you really quickly those rocks that you saw in the slides. This is conglomerate. These are pebble-sized sediment. This is sandstone, sand-sized sediment, shale, mud-sized particles, and this has fossils in it. Limestone, which forms biochemically in the ocean. And then finally, our coquina, which it's got lots of shells in here. Can you see all those shells? Okay, now very quickly, I'm going to show you three kinds of coal. This is lignite. This is what we have in Texas. It's dark brown. It's 80% carbon. It doesn't burn real hot, but we use it because it's what we have. This is bituminous coal. It's harder, burns hotter. We get this from Wyoming. And then we've got some anthracite. And anthracite's probably what you think of when you think of coal. It's very hard, shiny, it burns real hot because it's got a high carbon content. If you have any questions about the formation of sedimentary rock or fossil fuels, Mr. Broughton will be happy to help you with that. Thank you. Bye-bye.
Thank you, Mrs. Fuller. I guess first we have Gabriella, Jacqueline, Allison, Victor submitted the question and answer form, but did not type in their question. So if you do have a question, make sure you type it in before you click submit. But Jesus did ask a question. Can humans do weathering? And yes, we can. In fact, we do a lot of weathering by breaking up rocks to build roads or do other things like that, mining. We weather rocks quite a lot. So animals do it, but humans also do it too. All right, now we are going to look at canyons and deltas with Miss Nash.
Oh, there we are. Welcome to my classroom. Welcome to my classroom. So canyons and deltas. So canyons are formed by erosion. Deltas are formed by deposition of sediment. So you already went over those words. So just remember that canyons tend to be steep and deltas tend to be very flat. Canyons form from erosion, mainly by water, and deltas form from deposition of sediment by gravity. Now I've got a little apparatus here called the sedimentator, and I can get lots of stuff in it and water. I shake it up and all mixed in there. This is what happens with erosion. Things get pulled off and mixed up. But then as the river slows down, things begin to be deposited. Deposition, gravity pulls things out. And what we get are big pebbles, like those big rocks you saw from the flash flood in Arizona, then sand, and last, the silt. Okay. So if over time an overburden piled up on top time goes by, we'd have that conglomerate, sandstone, and shale forming. But that takes a long time. So in the meantime, this top layer of silt, the little stuff that's held in suspension a lot longer, okay, stays up in the water, it deposits last. Okay, and that's what causes a delta to form. Now we're looking at a few pictures of some amazing things that someday I hope you can go visit. Okay. And there they are. Here they are. Okay, so canyons and deltas. So let's start with canyons. So they're so amazing and beautiful. So in the center and on the bottom left, that Grand Canyon, the Colorado River going down the center, formed that canyon over thousands and millions of years. There are lots of side canyons with little creeks in them that also formed little smaller canyons, and they all come together in the Grand Canyon. It goes on for a long way, and the river's dropping really pretty rapidly. There are big rapids in it. You can go down that river in a raft and go over rapids and all kinds of amazing things to look at. It takes like 12 days to go down the river, and amazing thing to see. Ever get a chance to go look at it? It's a national park in Arizona. On the top right is another canyon called Bryce Canyon, and on the bottom a Slot Canyon. Those are both in Utah. So these are desert areas now. So canyons can also form in non-desert areas. So these are very green, and so the plants are growing along the sides, and they're doing two things. The roots will hold the soil, okay, to prevent a lot of erosion, maybe, but they also go into the rock and break it apart. And you can see in the top left that that river or creek is running pretty quickly. You can see that white water in it. That means it's going fast, and that aids in erosion, how fast the water is moving. We have canyons in Texas too. The most famous are the Santa Elena on the right-hand side in Big Bend National Park, and that's the Rio Grande going down. You can see the color of that river is brown. Why do you think that's brown? It's got all that sediment in it that came from upstream. Okay? And it's going to be dropping out gradually. As the river slows down, that sediment falls out. And on the left is the Palo Duro Canyon State Park. It's out in West Texas, and you can see a little creek down the middle. But this canyon is very wide. Okay? And again, these are really amazing places to visit and not that far away. Now, deltas form as the river slows down. It's to slow down, and all that sediment's falling out. And the rivers may meet the sea or flow into a lake. The river brings sediment down, and see the big loops there on the top left? That means it's not running very fast anymore. And when it loops around and loops, they call them meanders, they may get cut off. And then all that sediment just falls out. And you can see how the little channels get smaller and smaller. On the bottom left, you see all that brown stuff? That's all sediment being deposited. And up here you see farms, because that soil tends to be pretty good soil for farming. On the bottom left, we see a cold place, and a glacier up here in the top is melting. That river ice is melting. And as it melts, okay, and forms a liquid water river, it can also form a delta. So deltas, again, can form in different places on the planet. This is my favorite, amazing delta called Okavanga, where the river comes into not a lake, not an ocean. It comes into the middle of a giant desert called the Kalahari. And so the water just kind of goes and eventually just soaks into the ground and disappears. It doesn't go anywhere. But in the rainy season, like on the left, you can see that river just looping around, meandering. It's going very slowly. And there's water everywhere in the rainy season. You can see up here in this picture, like old meanders, okay, where the river was last time, maybe. And then you see our elephant friends there. They love that water, they love all that vegetation to eat. They need to eat it a lot every day. But then the dry season comes and that river begins to dry up completely. Okay? And you see those meanders getting smaller and smaller, cut off in the ground, no more grass growing there. Those elephants have to walk a long way to find something to eat. And down here, one last water hole for the animals to drink. So it's a really amazing place. The most amazing trip I've ever taken in my life was to the Botswana and the Okavanga. Amazing. We also have deltas in Texas. So on the Gulf Coast, you can see the rivers. We don't have really big rivers, but for Texas, we think they're rivers. But they bring a lot of sediment. Okay? They bring a lot of sediment with them. And you can see all that sediment being deposited here. They're flowing into the Gulf of Mexico. So in that case, the waters from that delta area mix with the ocean, and it creates a unique habitat for some amazing, really special birds. This is one of the most endangered birds on the planet, the whooping crane. And it's right there on the Gulf Coast in the Aransas National Wildlife Refuge. You can go down there and see that someday too. So pretty amazing things to see just right here in Texas. I think that's our last one. Yeah. One thing you can do is to go outside and go, it's been raining, go see if you can find a tiny gully, like a mini canyon forming, or all our creeks around here in Dallas cut down deep channels. So they go pretty fast when it rains. We have heavy rain all at once, and that creates a lot of water flow that can create a lot of erosion. You can see that happening in your own neighborhood or in the neighborhood park. So go explore and see what you can see in the way of canyons and maybe even some deltas forming. So if you have any questions, Mr. Broughton Lyons.
Thank you, Ms. Nash. The first question we got came from Eric at Gill Elementary, and he asked, are plankton small bacteria in the water? And plankton are not bacteria. Plankton they are microscopic organisms, but they mostly are diatoms, protozoans, small crustaceans, and the eggs and larval stages of larger animals. So they are not bacteria. That's actually even smaller than plankton. And then Angel asked, have canyons and deltas been there for millions of years? And yes, they have. Especially like the Grand Canyon. If you look at the rock formations and fossils in there, they are millions of years old. So now we are going to move on to another landform, which is sand dunes with Mr. Ramirez.
Hello, my name is Ms. Ramirez, and in this segment, we're going to be learning about sand dunes and their formation. So I'm going to go ahead and share my screen with you guys so we can start our presentation, and it might take just a second to get that going. So we're learning about sand dunes, and I actually created my own replica of a sand dune. So I'm going to show y'all a quick little video, and I want y'all to make some observations. So think about, what do you see, and think about any questions or wonderings you might have. Now you can replicate the same experiment at home if you have a straw and sand. And if you don't have sand, you can try potting soil. You can even try it with sugar or salt and see what types of sand dunes you can form. So again, as you're watching this video clip, think about, what do you see happening and why? And I'm just blowing through a straw. Also think about the movement of the sediment. Where is it going and what's happening? And then another question for y'all, what is the force of nature or the agent that's being represented in this model? And I'll give you a hint, the straw represents it. So I'm gonna go ahead and stop the video there, and hopefully you guys said that the agent or the force of nature in this case is wind, and it is wind that helps to create and form our sand dunes. So we're talking about sand dunes today, so there's just a couple of quick vocabulary words that we're going to go over. So let's take a look at question number 1. Wind can blank sand, moving it long distances. Now you've already heard these words several times with the other teachers, so let's see if you can remember it. What is the science word for when sediment or in this case, sand, is being moved. And it starts with the letter E. So for number one, hopefully you guys said, when can erode sand? And erode just means to move. So number two, when the wind blanks or drops a lot of sand in one area, sand dunes form. So what is the scientific word for when sediment is being dropped in a new location? And I'll give you a hint, it also starts with the letter D, and so that's how I remember it. And you've already heard this word several times with the other teachers. So hopefully you guys said the wind deposits or drops that sand in a new location. And then question number three, true or false? The shapes of sand dunes are constantly changing. So what do you think? And I'm going to show you a video in just a second to help you with that question. Now, we actually have sand dunes here in Texas, and it's located at the Monahans Sand Hill State Park, and that is in Monahans, Texas. It is near Odessa, Texas. So if you've ever driven down toward El Paso or to Mexico, you probably passed through Odessa or Monahans. And so the picture that you're seeing here is of two girls that are actually sandboarding. So I know here in Texas, we don't get a lot of snow, so we can't go sledding down the snow, but we can definitely go sandboarding. So that looks like a fun little activity to do. And then just to review, erosion is that movement of sediment. And once it's done moving, it has to stop somewhere. So we call that stopping and dropping of sediment deposition. So those are two very important vocabulary words when we're talking about landform formation. And then in our next slide, we're going to show you guys a video. This is a video of the Oregon Dunes National Recreation Area. So as you watch the video, think about what do you see and what do you wonder, and then see if you can use this video to help answer that last question in the previous slide as to whether or not dunes are changing. And as you guys are watching this little video of sand dunes, I'm going to give you some information on this. So this is actually 40 miles of dunescape in Oregon. Some of these dunes are as high as 500 feet tall. And this is actually the largest expanse of coastal sand dunes in North America. Now, these sand dunes are dynamic habitats, and that means that they are constantly changing. So they're affected by wave action. So we said this was a coastal dune, so it is by an ocean. It's affected by tides. It's affected by the wind, obviously, as you can see, and also trampling. So when there's a lot of people and tourists that are coming by, we actually can affect sand dunes as we're visiting them. Also, these sand dunes are important habitats. So lots of animals like rodents, snakes, lizards, they all can burrow in the sand dunes, and they actually call it sand swimming when they're burrowing through those sand dunes. And then sand dunes can actually change. So smaller dunes reshape and move faster than the larger ones. Smaller dunes are called baby dunes or embryonic dunes, and they can move up to 40 feet a year, while the larger ones can only move about 8 to 12 feet a year. However, that also depends on if there's any vegetation. So if there's any plants that might be growing there, those plant roots actually help to keep some of that sand in place, so it kind of slows down its movement. So I'm going to stop our little video and we're going to go over to our next diagram. So this is a diagram that helps better explain what's happening in sand dune formation. So here we have the wind that's going from the left to the right, and we call this the windward side, the direction that the wind is blowing. You can see that as the wind is blowing, it's picking up some of the sand particles and it's carrying it or moving it in the new direction. Some of those sand particles will get stuck at the crest, which is at the top of the dune. And eventually at a certain height, some of those sand particles might begin to tumble over the other side. So as they're tumbling, what force is pulling the sand down the other side of the slope? So hopefully you guys get this one right. The force that pulls things back down to Earth is gravity. So gravity is also very important in our sand dune formation, and they are falling down the side called the leeward side. So we have the windward side, which is actually the larger and longer side of the sand dune. And then we have the leeward side, which is the opposite side that the wind is blowing. So we know that again, sand is eroded, it's moved, and then sand is deposited, it's dropped in a new location to form our sand dunes. And then here's a quick little video. Scientists actually replicated a wind tunnel to better understand how sand particles are being picked up and moved. So make some observations as you watch this video. This process is actually called saltation, and saltation is Latin for leap. So hopefully as you're watching the video, you're able to notice that some of those sand particles look like they're jumping or leaping. So as the wind is blowing, it's lifting those small sand grains off the ground, and they're eventually dropping due to gravity. When they hit the ground, they may jump due to the impact, and they might hit other grains of sand as well, causing those other grains of sand to also jump up and be caught by the wind. So it's rather interesting how the wind and the sand particles are able to move around like that. And then there's also different types of sand dunes. So while I'm talking, make some comparisons, maybe compare and contrast the different types of sand dunes that you see here in the diagram. Sand dunes are affected by wind direction, also wind speed, and the amount of sand that's even available. So all three of those factors will determine what type of sand dune is eventually formed. And if we take a look at this picture here, it says, what direction is the wind blowing? And y'all can make a quick guess. Hopefully y'all remember that most sand dunes, the windward side is going to be the longer or the larger side. So if we look at this diagram here, we know that the wind is blowing in this direction. And then our last little slide is just a reflection question. Think about, how does weathering, erosion, and deposition create landforms? And then give some examples. So here in that pretty picture here on the bottom, that is the Star Dune. It is over 755 feet tall, and it's part of the Great Sand Dunes of Colorado. So we do have some amazing sand dunes here in the United States, and I highly encourage you guys, if y'all have the chance to ever go to that Monahans sand dune in Texas as well. So I'm going to stop our screen share, and that is all I have for you guys for sand dunes and their formation. We're going to pass it back to Mr. Broughton, and he's going to answer any questions.
Thank you, Mr. Ramirez. Eric asked a question that is, where does the river water come from? And Mr. Ramirez showed a picture that sort of illustrates where river water comes from. It comes from, generally speaking, up in mountains or high hills. So whenever it rains in the mountains, the water runs down the mountain and into a river, and that's where the water comes from. Or if snow melts in the mountains, that water runs down into a river, and that's where our river water comes from. All right, now we're going to look at how to use a stream table with Mr. Monroe.
Good morning, students. My name is Mr. Monroe, and we're going to be looking at stream tables. You know, when a stream or river flows downhill, it can change the landscape. A stream table is an excellent working model to show how that landscape can be changed by eroding rocks and deposition of sediments, which you've heard some of the other teachers refer to. A stream table can be used to demonstrate many water concepts and principles that are associated with flow rate, velocity, channel slope, erosion, and deposition, which our simple tables that we're going to be using today will kind of focus on, and stream bank stabilization. Now, the two stream tables that I'm going to be using to demonstrate today with, they're very simple. Something that you probably could construct if you had the right materials, just very simple. But there are more elaborate ones, such as using a water pump with tubing, that basically you could study flow rate, you could study some of those other concepts and principles that are associated with water. Now, I'm going to be turning the camera down low and pick up this first stream table. So let me go ahead and do that. Hopefully you guys can see that. Okay, we're going to work with this one first. Now, I'm manually going to be putting the water in, and we're going to watch what happens. I'm going to start with using a graduated cylinder with 250 milliliters of water, and I'm going to try to pour it at a steady rate, and let's see what happens. It may take a little more water than what I'm pouring, so I've got to back up. Now, if we were using a tube, this would go a lot faster, or we could control the flow of water. Now, for some reason, our river, which we have created, we can see that, took off to one side. Now, you heard Ms. Nash talk about the depositing of sediments and silt when the water flow slows down, and we have that effect right here. So this area right in here would be considered a delta. Now, I can see why this river took this direction, simply because this area is a little bit higher in elevation. So gravity and water, guess what? They are I guess I would consider them the strongest agents of erosion, as shown by here. This is a slope that the stream table is setting on. What do you think the effects would be if the slope was even up higher? Well, the next table we will do that. But here we see that the riverbed has been created, and we now have a delta here. Now, there is a river that every time I do this activity, I think about that river, and that's the Mississippi River. And that river is the largest watershed in the United States. It furnishes water for about 23 of the 50 states of the United States, okay? And it empties into the Gulf of Mexico. Where it empties into the Gulf of Mexico, that is called the Mississippi Delta area. And you guys heard Ms. Nash talk about how that area, because of the silt being deposited there, provides very rich farmland. The soil is very rich to grow crops in. Let's go ahead and set the next one up. Now, in this stream table, I've created a mountain. And we know that the very top of the mountain, the higher the elevation, the colder it gets. And we know that sometimes there's lots of snow at the top of a mountain. And I could have put some white sand or something up here to indicate that. But also when it rains and we got an abundance of precipitation or snow melts, it can create a water flow. So we're going to create a water flow, and let's see what kind of effect this will have. In the top. Okay, need a little bit more water. Okay, now, here we have created a canyon. We also have a riverbed here, and guess what? We also have a delta. Now, this kind of makes me think about how the Grand Canyon was formed. Through the Grand Canyon, the Colorado River runs, and so it has created the Grand Canyon. Of course, it doesn't run into a large body of water where it would create a delta. But I placed several rocks in here, and you can do a variety of things. I placed several hard rocks in here to see what kind of effect that maybe some types of different rock formations might cause a little bit of change in water flow. And we could see that. The water flow actually took a curve right here, and that's called a meander. When a river takes a bend, like Miss Nash says, that's a meander. So there are a lot of concepts that can be taught by using a stream table. Hopefully you guys kind of understand that. You might make one of your own at the house, but try not to create a big mess. Now, at this point, I'm going to turn it back over to Mr. Broughton. And if you guys have any questions, maybe he can answer those for you. Okay, Mr. Broughton.
Thank you, Mr. Monroe. The question that came in was, if I increased the slope or made that stream table steeper, would that cause more weathering and erosion? And you can try that for yourself, but I'm going to tell you, I think, yes, it would. If water has a way to move faster, it's going to be able to carry more pieces away. So that's more erosion. And then there's also going to be more deposition because it eventually has to get to the bottom of wherever it's traveling. So in this case, a stream table, and it would deposit more material at the bottom of that stream table as well. All right, now I'm going to share my screen here to do a quick recap of what we did today. So today's virtual field trip was all about Earth's changes. During this virtual field trip, students discovered that Earth's surface is constantly changing and consists of useful resources. Students explored the processes that led to the formation of sedimentary rocks and fossil fuels. Students also recognized how landforms are the result of changes to Earth's surface by wind, water, and ice. So we started things off by exploring how sedimentary rocks and fossil fuels form with Mrs. Fuller. Next, we explored deltas and canyons with Miss Nash. Third, we explored sand dunes and how they can change with Mr. Ramirez. And then we just saw how to use a stream table to model weathering and erosion and deposition to show different landforms with Mr. Monroe. Thank you so much for joining us this morning. We appreciate you taking the time to learn about Earth's changes with us. We hope you enjoyed this field trip, and you can let us know whether you did or not by going to www.tiny.cc/EEC feedback and filling out a short feedback form for us. We hope to see you again in February for our next field trip for fifth graders. Have a great rest of your day, and we'll see you next time. Goodbye.